Hello, this is the first video in Tkip video series on securitytube.net. Tkip is a part of WPA2 encryption protocol in IEEE 802.11. It is a temporary security patch. It is known as temporary security patch for IEEE 802.11 because the web or wired equivalent privacy, or also known as worst ever privacy, was the first part mentioned in IEEE 802.11, but it was found that web is having severe problems and it is easily crackable. You can easily crack the web key, and there are so many weaknesses involved with the web. And to patch this solution, the Tkip or WPA with Tkip was applied. Now Tkip is something which you can apply on the web hardware. It is stronger than web, but it is not the panacea. There are again problems with the web Tkip protocol, but it is reasonably strong protocol. In this video, firstly I will talk about some of the weaknesses of web protocol, then how Tkip is introduced, what new actions have been adopted in Tkip protocol so that the major weaknesses have been taken care of, and how exactly Tkip encrypted packet looks like and how that Tkip encryption takes place. I will be talking about how exactly the Tkip packet is encrypted, how it is exactly transmitted, what are other countermeasures applied for Tkip protocol, and again problems with Tkip protocol and some of the recently launched attacks on Tkip protocol in successive videos. This video is more introductory video for Tkip. Before going into detailed nitty-gritty of WPA Tkip protocol, let's first have a quick look of about the weaknesses of the web protocol. The first important weakness was the IV field length. In web, the IV field was too short. It was just 3 bytes or 24 bits. So after 2 to the power 24 packets, the IV field is bound to reuse, and believe me, 2 to the power 24 is not a very big number. It can be easily achieved with some spoofed packets. It can be easily achieved very quickly. And in web, the per packet key is constructed from IV and the key. So it was constructed like, take the IV or initialization vector, take the key which is shared between transmitter and the receiver, concatenate these two, and then with the help of RC4 algorithm find the key stream. And for encrypting the packet, this key stream itself was getting used. So first big problem was the key itself is used for encrypting the packets. So for some reason, if key gets compromised, it is clear that packet can be visible to anyone because IV goes as clear text over the wireless media. Second important problem, while creating the key stream with the help of IV and key, there is a weakness with RC4 algorithm. The weakness is, for some special IVs called weak IVs, there is clear correlation between the IV and the initial first bytes of the key stream. Now IV goes clear text over the wireless media, so for some IVs or for some weak IVs, the key stream or the first few bytes of the key stream were predictable. So the per packet key is constructed from IV, and there are weak IVs, and there is very bad message integrity protocol, or message tampering can be easily done. For message integrity, the ICV is present in the web case. ICV is integrity check vector, but for creating this ICV or integrity check vector, they have used some simple protocols, and those protocols can be easily tweaked with simple changes in the packets. The well-known chop attack is very much based on this weak message integrity protocol. Then again, as I said, master key is directly used for encryption and no key update is possible. The very basic fundamental of any encryption protocol, the master key or the master secret should be always preserved, and for encryption purpose you should always derive key from the master key, and at a certain interval you should change those encryption keys, but master key should never be used directly as the encryption key. But that itself is being violated in case of web, Again, there is no replay protection. If perfectly formatted packet is sent from sender to receiver, if the eavesdropper captures this packet and tries to re-inject this packet on the network again and again, there is no way the receiver can find out that these packets are coming from attacker or the eavesdropper and not the actual transmitter. There is no check which will say that this packet is from actual transmitter. That's another major problem with the web. You must be thinking, what is Tkip? I'm talking about Tkip for so long. What is Tkip? Tkip is temporal key integrity protocol. Why temporal? Because the key which is actually used is just temporary. After some certain period of time, certain time interval, these keys are changed, and it is integrity protocol. There is some special integrity check, not so simple integrity check implemented in this protocol. So it is the main importance in this protocol is that key is not permanent, it is temporary key, and a strong integrity check value is added here. Now this protocol is designed as a wrapper around web. Why this protocol was introduced? It can be implemented in software. Now web hardwares were already present in the market. Now it is not possible to ship again hardware to every vendor. So the simplest solution can be a implementation which can be easily fit over web. So everything should happen in software. Now if I start calculating the expensive things, expensive encryptions in software, of course my protocol, my transmitter, my receiver will become very much slow, and the high data rate communication will not be possible. So my protocol should be simple. It should be so simple that it should not act as a burden for encryption. So it should reuse the web existing hardware, and it should run as a web subcomponent. So you must take into mind it's a quick fix. So there are problems with WPA Tkip. It's a quick fix for the web, but it is considerably strong. It is not easily possible to break into WPA Tkip protocol. And new procedures around legacy web. Now we know web and we know problems with web. So for designing Tkip, what all things that we need? First thing is, never use same IV value more than once for any particular session key. So for a given key, now first important thing, never use the shared secret. Master key will be never used. For a session keys will be derived with the help of master key, and that session key will be used actually for encryption. Now in any session, never use the IV or initialization vector again. The same initialization vector will occur only once. That initialization vector will never be reused in the same session. Second important thing that we have learned from weaknesses of web: receiver has to discard any packet whose IV value is less than or equal to the last successfully received packet, encrypted with the same key. Encrypted with the same key, that is the same session. So in a session, if receiver receives any packet with whose value is less than or equal to the successfully received packet. So if if in my transmitter is transmitting initialization vector number 1000, and after transmission of this IV 1000, receiver has successfully acknowledged this 1000 IV. Now my eavesdropper has captured this 1000 IV. Now my transmitter will transmit 1001. Receiver will receive 1001. It will transmit 1010. Receiver will receive 1010. And after that, the eavesdropper is resending the packet with IV 1000. Now my receiver will never accept any packet less than 1010 because its current acknowledged packet was 1010. So any packet which is less than the last acknowledged packet will not be accepted. Any IV which is less than the last acknowledged IV will never be accepted by any device, which suffices the reuse or retransmission problem with the web. Prevents replay attack. Okay, now third important thing is regularly generate a new random session key before the IV counter overflows. Now whenever this IV counter will overflow, before that overflow happens, you need to change your session keys so that the IV reuse in the same session will be always prevented. And provide a more and thorough mixing of the IV value and the session key to derive the packet's RC4 key. Now there is some problem with the IC4 that if you know the IV, and with the help of IV and session key, if you just concatenate the IV and session keys as it is, there is a well-known problem with RC4 that for some IVs the key stream will be predictable. So in short, don't just concatenate IV and session key, but do some more mixing so that the RC4 key stream will not be as simple as web to predict. To fix the RC4 key scheduling issue with web.